Our first pattern is called modus ponens. We keep the Latin because it's been used for so long. But we're just going to abbreviate it, MP. The pattern looks like this. I'm going to use the variables P and Q to demonstrate the pattern, but it could be any variables at all that we use. If we know this, right, if we know that P implies Q, P implies Q is another way of saying if P, then Q. If we know that this is true, and then we learn that P really is the case, we can conclude that Q must be the case. So if you know that if a patient tests positive for a certain disease, if a patient tests positive on a certain test, they have a certain disease, and then you get the results back and they do in fact test positive, well, you would infer that they have the disease. This is a very common pattern. It's a pattern that we all use quite a bit. Let's say you're an athlete, and you know that if someone steps on the line, they lose possession of the ball. You go ahead and you step on the line. What happens? You've lost possession of the ball. It's almost like we have a rule up here, and then what happens is this first thing happens. It's called the antecedent. This antecedent occurs. Here we're told if P occurs, then Q is the case. But we don't know if P occurs just from this one line. It's the second line that tells us that P really did happen. Therefore, Q really is the case, right? If I won the lottery, I'd be rich. That doesn't mean I've won the lottery. But if it actually turns out that I do win the lottery, it follows that I'm rich. This is the basic idea behind modus ponens. Now, this is the form, and this form can appear in lots of different ways. So here's a very simple example of modus ponens that you might see using other variables. This is modus ponens too. Doesn't make a difference if we're talking about P's and Q's or A's and B's. Same basic idea. If A, then B. A occurs, therefore B is the case. But this is also an example of modus ponens, and this can be where things get a little tricky. This is also modus ponens. Why? Line 1 is an if-then statement. It's a more complicated if-then statement, but it is just an if-then statement. What line 1 tells me is that if X and Y are both true, then not C must be the case. Line 2 tells me that X and Y are both true. Therefore, not C is the case. Here's how you want to think about this. Think about this as if this were P implies Q. P is the case, therefore Q must be the case. In other words, the little pattern that we learned in P's and Q's, that can apply to more complicated statements. I'll give you another example. This is modus ponens. We're told in line 1 that if either A or B is the case, then both C and F must be true. Line 2 tells us that A or B really are the case. Therefore, we can conclude that C and F are true. In other words, this is like saying if P, then Q, P, therefore Q. The P's and Q's can stand for anything, no matter how complicated it gets, in an if-then statement. And then if that P occurs, if we find out that that P is true, we know the Q is true. So let's do our first proof. Let's do a really simple proof using only our one rule, our one valid pattern, modus ponens. If I told you in line 1, if A or B is true, then C must be true. And in line 2, I told you A or B is true, and your goal was to show me why C must be the case, this is what you would do. You would recognize, because of modus ponens, C has to be true. And you would tell me, okay, I can add to what I know. I'm going to add a line, let's call it line 3, and I'm going to be able to say that C is true. And how am I justified in saying that C is true? The valid pattern called modus ponens, using lines 1 and 2. And that's exactly what I write down. I justify the fact that I've added information. I justify it by using the name of this valid pattern, or this rule, called modus ponens, and the 2 lines that I'm referring to. So this is a very, very simple proof, but look at what we've done. We've taken information that we've been given, and we've drawn new information out of it, and that's the power of deduction. Based on what we're given, we can draw out new information with certainty. Our first rule that allows us to do this is called modus ponens.